The sea off Antikythera is the colour of old bruises in April, purple and black where the depths drop away, green where the light still reaches, and everywhere the chop of wind that the locals call the Meltemi, though it is not yet summer and this wind has no name. The year is 1900, and the sponge divers of Simi have come to these waters because the sponges here grow fat on the nutrients that pour through the strait between Crete and the Peloponnese. They are not looking for anything but sponges. They are not thinking about history. They are thinking about money, about the merchants in Alexandria who will pay good prices for the best Mediterranean sponges, about their wives and children back on Simi, about the cold that seeps through their canvas diving suits even in spring. The technology they use is called the scaphandro, and it is brutal. A copper helmet bolted to a waterproof suit, air pumped down through a rubber hose from a hand-cranked compressor on the deck above. The divers breathe what the men above choose to give them. They sink like stones into water that grows colder and darker with every fathom. At depth, the pressure squeezes their bodies, forces nitrogen into their blood, turns their joints into grinding hinges of pain. Many of them will die young. Many of them already have. The ones who survive are hard men, calloused in places that never see the sun, intimate with a darkness that most human beings will never know. Captain Dimitrios Kondos commands the boat. He's from Simi, like his divers, and he knows these waters well enough to fear them. The strait between Crete and the mainland is a graveyard. Ships have been dying here for 3,000 years, driven onto the rocks by sudden storms, dragged down by currents that seem to come from nowhere. The seabed is littered with amphorae, with anchors, with the bones of sailors who prayed to gods that could not hear them through the weight of all that water. Kondos knows this. Every sponge diver knows this. They work around the wrecks like farmers work around old stones in their fields, obstacles to be noted and avoided, nothing more. On this particular day, a diver named Elias Stadiatis descends into water that is perhaps 60 meters deep. This is dangerous depth, the kind of depth where mistakes become fatal, where the nitrogen in your blood starts to whisper lies to your brain. Stadiatis is experienced. He has done this hundreds of times. He knows how to read the seafloor, how to spot the sponges clinging to the rocks, how to work quickly and efficiently so that he can return to the surface before his air runs out or his body betrays him. What he sees when he reaches the bottom stops his heart. Bodies. Dozens of bodies strewn across the seafloor like casualties of some ancient massacre. Arms reaching upward. Faces frozen in expressions of agony. Horses too. Horses lying on their sides in the silt, their legs tangled, their manes floating in the current like the hair of drowned women. Stadiatis panics. He yanks on his signal line, the universal sign for emergency ascent, and the men above haul him up as fast as they dare. When they pull off his helmet, he is pale and shaking, babbling about a field of corpses, about the dead reaching for him from the darkness. Captain Kondos does not believe in ghosts, but he believes in his diver's terror. He puts on a suit himself and descends to see what Stadiatis saw. What he finds is not a massacre, but a museum. The bodies are bronze statues, green with verdigris, their surfaces eaten by 2,000 years of salt water, but their forms still recognizable. A philosopher with his hand raised in declamation, a young man with the proportions of an athlete, a horse that must have been part of a chariot group, life-sized and magnificent even in ruin. Kondos understands immediately what he has found. This is a Roman ship, or perhaps a Greek one pressed into Roman service, and it was carrying art, probably looted art, probably bound for Rome in the years when Rome swallowed the Greek world whole and carried its treasures away like a conquering army carries its plunder. He also understands that this discovery will change everything. The Greek government is notified. The Hellenic navy sends ships. For the next 2 years, the sponge divers of Simi become archaeological labourers, hauling statues and pottery and corroded lumps of unidentifiable material from the seafloor, while navy officers take notes and archaeologists argue about dates and provenance. The work is brutal and dangerous. One diver dies. 2 others are permanently paralysed by decompression sickness. The treasure they bring up is extraordinary. The bronze statues alone are worth more than anything the Greek state has recovered from its own soil in decades. Among the treasures is a lump of corroded bronze about the size of a shoebox. It is greenish-brown, encrusted with marine growth, and at first glance it appears to be nothing but a mass of fused metal, perhaps the remains of a statue's base, or a piece of ship's equipment. No one pays much attention to it. The statues are what matter. The statues are what the newspapers write about, what the museum directors fight over, what the scholars build their careers on. The lump gets catalogued, numbered, and placed in storage at the National Archaeological Museum in Athens. It will sit there, largely ignored, for more than half a century. Imagine a drawer in a museum basement. Imagine the particular smell of that basement. Old stone, older dust, the faint chemical tang of preservation fluid leaking from jars that were sealed decades ago. Imagine the quality of the light, which is the colour of weak tea, filtered through windows that have not been cleaned since before the war. Imagine the silence, which is not really silence at all, but the slow exhalation of a building that holds 10,000 years of human making within its walls. In this drawer lies an object that will rewrite the history of human technology. No one knows this yet. The object waits, time passes, the world goes to war twice. Greece suffers occupation, liberation, civil war, reconstruction. The National Archaeological Museum survives, its collections intact, its basement still full of artefacts that no one has properly studied. In 1902, a few months after the lump was recovered, an archaeologist named Valerios Stais examined it and noticed something strange. The corrosion had cracked in places, revealing what appeared to be gear wheels inside, bronze wheels with carefully cut teeth, meshing with other wheels, all of it fused together by 2 millennia of mineral incrustation, but still recognisably mechanical. Stais published a paper suggesting that the object might be some kind of astronomical calculating device. His colleagues dismissed him. They pointed out that no such device was known from the ancient world, that the Greeks had excellent theoretical astronomy, but nothing approaching the mechanical sophistication required to build gear trains, that Stais was probably looking at the remains of a medieval astrolabe that had fallen onto the wreck site from a later ship. The ancient Greeks, they argued, simply could not have built what Stais thought he was seeing. It was impossible, therefore Stais must be wrong. The lump went back in its drawer. The drawer went back in its cabinet. The cabinet sat in the basement while the decades rolled by overhead. The impossible object waited. This is how lost knowledge works. This is how civilizations forget what they once knew. Not through dramatic catastrophe, not through fire and sword, though sometimes that too, but through the slow, patient work of disbelief. Someone sees something that doesn't fit the accepted narrative. Someone publishes a paper that challenges what everyone knows to be true, and the guardians of the accepted narrative, the gatekeepers of orthodox knowledge, close ranks and say, "No, that cannot be what it appears to be, you must be mistaken." And so the impossible is placed in a drawer, and the drawer is closed, and time passes, and eventually everyone forgets that the question was ever asked. In 1951, a British science historian named Derek de Solla, Price, visited the National Archaeological Museum in Athens. Price was interested in the history of scientific instruments, particularly the history of geared mechanisms, clocks, astrolabes, orreries, the beautiful brass machines that Europeans had been building since the late Middle Ages to model the motions of the heavens. He had read Stace's old paper. He was curious about the lump. What he saw when he examined it changed his life. The mechanism, for Price immediately understood that it was a mechanism, a machine, a device of intentional complexity, was unlike anything he had ever encountered in his research. The gear teeth were cut with a precision that suggested careful mathematical planning. The wheels were arranged in configurations that suggested astronomical calculations, and the whole thing was embedded in bronze plates covered with inscriptions in ancient Greek, inscriptions that appeared to be instructions for the device's operation. Price spent the next 2 decades trying to understand what he was looking at. The technology available to him was limited. He could examine the visible surfaces with a magnifying glass. He could make plaster casts of the inscriptions. He could photograph the fragments, for the mechanism had broken into multiple pieces over the centuries, some still fused together, some separated by the violence of corrosion and pressure and time. But the interior of the mechanism, the place where the gears meshed and the secrets were kept, remained hidden behind walls of mineralized bronze that he could not penetrate without destroying the very thing he was trying to study. In 1959, Price convinced the Greek authorities to allow him to take X-rays of the mechanism. The results were revolutionary and frustrating in equal measure. The X-rays revealed the presence of at least 20 gear wheels, possibly more, arranged in a complex three-dimensional structure. They showed that the teeth were triangular, like the teeth of modern precision gears, and that they were cut with remarkable regularity. No two teeth measurably different from any other. They showed that the mechanism was not a crude prototype or a toy, but a sophisticated instrument built by someone who understood both astronomy and mechanical engineering at a level that historians had never imagined the ancient world could achieve. But the X-rays were flat. They showed shadows, not structures. They could not reveal how the gears meshed, what functions they performed, or what astronomical phenomena the device was meant to model. Price knew he was looking at something extraordinary, but he could not prove it. He could not reconstruct the machine's operation. He could not silence the skeptics who still insisted that the mechanism must be a medieval intrusion, a later artifact that had nothing to do with the ancient ship on which it was supposedly found. Price published his findings in 1974, 2 years before his death. His paper, Gears from the Greeks, made the case that the Antikythera Mechanism was a genuine ancient artifact of unprecedented sophistication, a geared calculator designed to predict the positions of the sun and moon, and perhaps the planets as well. The paper was well received in some quarters, dismissed in others, and largely forgotten by the mainstream of classical scholarship. The mechanism went back in its case. The case went back in the museum. The question of what the ancient Greeks had actually built remained unanswered. 3 more decades passed, and then, in 2006, a team of researchers led by Mike Edmonds of Cardiff University brought a device called the Antikythera Mechanism Research Project to Athens. The device was a custom-built X-ray tomography scanner, a machine designed to take 3-dimensional images of objects by combining hundreds of X-ray exposures from different angles. It was the same technology used to look inside the human body without cutting it open, the same technology used by airport security to peer inside luggage. But this scanner was built to handle an object 2,000 years old, an object so fragile that touching it too roughly might destroy it forever. What they found inside the mechanism was impossible. 37 gear wheels, not 20, some of them less than a centimetre in diameter, all of them cut with teeth that deviated from perfect regularity by less than 1/10 of a millimetre, pin and slot mechanisms that allowed one gear to drive another at a variable rate, compensating for the elliptical orbits of celestial bodies. A differential gear train, the same technology that allows modern automobiles to turn corners smoothly, used to calculate the difference between the solar and lunar calendars. An epicyclic gear system that modelled the apparent motion of the moon, including its varying speed as it swings closer to and farther from Earth in its elliptical orbit. The inscriptions too came into focus. The tomography scans revealed text that had been hidden beneath the corrosion, text that no human eye had seen since the mechanism sank beneath the waves. The text was a user's manual, instructions for operating the device, explanations of what each dial and pointer displayed, references to astronomical cycles that the Greeks had discovered through centuries of patient observation. The mechanism could predict solar eclipses. It could predict lunar eclipses. It could track the positions of the 5 planets known to the ancient world, Mercury, Venus, Mars, Jupiter, and Saturn, through their complex wandering paths against the fixed stars. It could calculate the dates of the Olympic Games, the Isthmian Games, the Pythian Games, the Nemean Games, the great athletic festivals that structured the ancient Greek calendar. It did all of this through the purely mechanical motion of bronze gears, with no electricity, no computers, no digital logic of any kind. It was, in every meaningful sense, an analog computer, built around 150 BCE, lost at sea, forgotten, dismissed, and then finally understood. 2,000 years after its creators placed the last gear in its housing and wound the mechanism for the first time. Here is what the Antikythera Mechanism means. It means that someone in the ancient Greek world, probably in Rhodes or possibly in Syracuse, or perhaps in one of the great libraries of Alexandria, understood mechanical engineering at a level that would not be matched again until the Renaissance. It means that the Greeks had not only theoretical astronomy but practical technology, the ability to translate mathematical models into working machines. It means that the gap between the ancient world and the modern world is not as wide as we thought, that human beings were capable of extraordinary feats of precision manufacturing more than 2,000 years ago. But here is what the Antikythera Mechanism also means. It means we almost lost it forever. The mechanism survived because a Roman ship carrying Greek treasure sank in a particular place at a particular time. If the ship had made it safely to Rome, the mechanism might have been melted down for scrap, or placed in a wealthy patron's study and forgotten, or passed from owner to owner until its workings were no longer understood and it was discarded as a broken curiosity. If the ship had sunk in deeper water, beyond the reach of sponge divers, the mechanism would still be lying on the seafloor, unknown and unknowable. If the sponge divers had been working a different stretch of coast that April, the wreck might not have been discovered for another century, or ever. The Antikythera Mechanism is the only device of its kind that has ever been found. There are no others. There are no precursors, no simpler machines that show the development of the technology from primitive to sophisticated. There are no successors, no later improvements or variations on the design. The mechanism exists in total isolation, a single data point in a void of lost knowledge. And the questions that data point raises are deeply unsettling. Because if the Greeks could build this, what else could they build? What other machines existed in the workshops of Rhodes and Alexandria and Syracuse that we have never found? What technologies were developed and lost, perfected and forgotten, invented and reinvented across the long centuries of human history? We know, from fragmentary references in ancient texts, that the Greek engineer Archimedes built machines of extraordinary sophistication, war machines that defended Syracuse against Roman siege, astronomical devices that modelled the motions of the heavens, automated theatres that performed entire plays without human intervention. We have none of these machines. We have only the stories, the legends, the second-hand accounts of travellers who saw wonders they could not explain. We know, from other fragmentary references, that the Library of Alexandria contained hundreds of thousands of scrolls, the accumulated knowledge of the ancient Mediterranean world, mathematics, astronomy, engineering, medicine, philosophy, history, literature. We have a tiny fraction of what the library once held. The rest was lost to fire, to neglect, to the simple entropy of papyrus and ink and time. What was in those lost scrolls? What did the ancient world know that we have forgotten? The Antikythera Mechanism is a message from a past that was far stranger than we imagined. It tells us that our assumptions about what ancient people could and could not do are wrong, that the narrative of steady technological progress from primitive to advanced is a fantasy we tell ourselves to feel good about the present. Human history is not a smooth upward curve, it is a jagged line, full of peaks and valleys, full of heights achieved and then lost, full of knowledge that existed and then vanished as completely as if it had never been. This is a documentary about what happens when the impossible refuses to stay buried, when the things we have lost wash up on distant shores, encrusted with salt and verdigris, waiting to tell us secrets we are not prepared to hear. It is a documentary about 5 objects that should not exist. The Antikythera Mechanism is the first. The story does not end with the Greeks. It does not end in the Mediterranean. It reaches across continents and across millennia, into the deserts of Iraq and the mountains of California and the deep mines of South Africa. It reaches into places where the very concept of human technology becomes meaningless, where the objects we find challenge not just our understanding of history, but our understanding of what is possible. Consider Iraq in 1936. Consider a landscape that had seen the rise and fall of civilizations for 6,000 years, longer than any other place on Earth. Babylon, Assyria, Sumer, Akkad. Names from the oldest stories humanity has ever told, names inscribed on clay tablets that were ancient when Homer sang of Troy. This was the land between the rivers, the Tigris and the Euphrates, the cradle of everything that would become civilization: writing, agriculture, mathematics, law, religion, empire. In 1936, the land between the rivers was a nation called Iraq, only 15 years independent from the British mandate that had carved it from the corpse of the Ottoman Empire. Baghdad was its capital, a city of minarets and markets, of date palms and dust, of scholars and soldiers and merchants who had traded goods along these routes since before the pyramids were built. The excavation was not particularly notable. Workers digging near the village of Kujut Rabu, about 20 miles southeast of Baghdad, had uncovered a cluster of graves dating to the Parthian period, roughly 250 BCE to 224 CE, the centuries when the Parthian Empire controlled Mesopotamia and served as Rome's great rival in the east. The graves contain the usual array of burial goods, pottery, jewellery, glassware, the small personal items that ancient people believed the dead would need in whatever afterlife awaited them. Among these items was a clay jar about 5 inches tall, unremarkable in appearance, a simple terracotta vessel with a narrow neck and a rounded body, the kind of container used throughout the ancient world for storing oils, perfumes, small quantities of precious goods. But this jar was not empty. When the archaeologists looked inside, they found a copper cylinder, and when they looked inside the copper cylinder, they found an iron rod. The arrangement was peculiar. The copper cylinder fit snugly inside the clay jar, held in place by an asphalt plug at the neck. The iron rod was suspended inside the copper cylinder, also held by asphalt, but not touching the copper walls. There was a small gap between the iron and the copper, as if the builder had deliberately kept the two metals separate. The whole assembly gave the impression of careful, intentional design, but its purpose was completely unclear. The jar ended up in the collection of Wilhelm König, a German archaeologist who served as director of the National Museum of Iraq in Baghdad. König was intrigued by the object. He had seen thousands of Parthian artifacts, but nothing quite like this. The combination of materials, ceramic, copper, iron, asphalt, suggested some specific function, but what function would require a metal rod suspended inside a metal cylinder inside a clay jar? König had a theory. He had noticed that if the space between the iron rod and the copper cylinder were filled with an acidic liquid, vinegar, grape juice, citrus juice, any of the mild acids that were readily available in the ancient world, the assembly would function as an electrochemical cell, a battery. The acid would react with the two different metals, creating a flow of electrons from the iron to the copper. It would not be a powerful battery, perhaps 1 to 2 volts, barely enough to feel if you touched both terminals, but it would be a battery nonetheless. König published his theory in 1940, just as the world was tearing itself apart for the second time. The timing was not propitious for academic papers about obscure archaeological finds from Iraq. The theory received some attention, some skepticism, and was then largely forgotten in the chaos of the war years. But König's theory would not stay buried. In the decades after the war, engineers and hobbyists began building replicas of the Baghdad battery, and the replicas worked. A terracotta jar, a copper cylinder, an iron rod, a splash of vinegar. The voltage was small but measurable. The current flowed. The implications were staggering. If the Baghdad battery was actually a battery, if it was designed and built to produce an electrical current, then the Parthians had discovered one of the fundamental principles of electrochemistry, roughly 2,000 years before Alessandro Volta published his famous paper on the voltaic pile in 1800. They had understood that different metals separated by an electrolyte will generate an electric current. They had not merely stumbled upon this knowledge by accident, they had built a device to exploit it, a device with specific proportions and materials chosen for their electrochemical properties, and they had done this in the 3rd century BCE at the latest, possibly earlier. But what did they use it for? This is the question that has haunted researchers for 80 years, and it has never been satisfactorily answered. The most common theory is electroplating. If you run an electric current through a solution containing dissolved gold or silver, the metal will deposit as a thin layer on whatever object you connect to the negative terminal. Modern jewelers and manufacturers use this process constantly. It's how cheap jewellery gets its gold finish, how chrome bumpers are made, how the contacts on your electronics are coated with corrosion-resistant metal. The process is simple, well understood, and well within the capabilities of a culture that had the Baghdad battery. And there is some supporting evidence for this theory. Archaeologists have found Parthian and Sasanian objects, vases, statuettes, decorative items, that appear to be made of gold or silver, but are actually made of base metals with a thin precious metal coating. The coating is sometimes remarkably even and uniform, more so than you would expect from simple gilding or leaf application. It looks, to some observers, like electroplating. But there are problems with this theory. First, no direct evidence has ever been found linking the batteries to electroplating operations. No residues of gold or silver solutions in the jars, no plating workshops containing batteries, no written or pictorial references to the process. Second, other methods of gilding were well known in the ancient world: fire gilding, leaf application, mercury amalgam, and these methods work perfectly well without electricity. Why would the Parthians have invented a new, more complex process when the old processes served their needs. Another theory suggests medical applications. Mild electric shocks have been used therapeutically for centuries, to stimulate muscles, to relieve pain, to treat neurological conditions. The electric eel was known to the ancient world, and its shocks were sometimes applied to patients suffering from headaches or gout. Perhaps the Baghdad battery was a way of generating similar shocks without having to keep a live eel on hand. But again, the evidence is thin. No medical texts from the Parthian period mention electrical therapy. No medical instruments have been found that could plausibly be connected to the batteries. The theory is possible but unprovable. The strangest theory involves religious ritual. Imagine a temple in ancient Mesopotamia. Imagine a statue of a god, cast in bronze or carved from stone, placed in a shrine where worshippers come to pray. Now imagine that the statue is wired to a hidden battery. When the worshipper touches the statue's hand or kisses its metal lips, they receive a small electric shock, a tingling, a spark, a sensation that might be interpreted as divine power flowing from the image into the supplicant. Would this have been theologically significant? Would it have reinforced faith, demonstrated miraculous power, convinced the skeptical and awed the credulous? We cannot know. But the manipulation of religious experiences through hidden technology is not unknown in the ancient world. The Greeks built automated temple doors that opened on their own when a fire was lit on the altar, using steam pressure and hidden counterweights. The Egyptians built speaking statues that delivered oracles through hidden tubes and chambers. The idea that Parthian priests might have used electrical effects to enhance their rituals is not implausible, even if it remains unproven. The truth is that we do not know what the Baghdad battery was for. We can replicate it. We can prove that it works as a battery. We can speculate about its uses. But the people who built it left no records, no instructions, no explanations. Their knowledge, whatever it was, died with them. And there is something else, something that makes the mystery deeper. The Baghdad battery is not unique. Dozens of similar jars have been found at sites throughout Mesopotamia, dating from roughly the same period. They are not identical. There are variations in size, in the proportions of the components, in the materials used for the seals, but they share the same basic design: a ceramic container, a copper cylinder, an iron rod, the same three-part structure that generates a current when filled with acid. This was not a one-off experiment, not a single inventor's lonely discovery. This was a technology, a known, repeated, reproducible technology that spread across a geographic region and persisted for generations, perhaps centuries, and then it vanished. By the time the Sasanian Empire fell to the Arab conquest in the 7th century CE, the technology of the Baghdad battery was gone. The Arabs who inherited Mesopotamian civilization, who built upon its mathematics, preserved its astronomy, translated its philosophy, knew nothing of electrochemistry. The knowledge simply disappeared, as if it had never existed. For 1200 years, no one on Earth knew how to build an electric battery. Not in Europe, not in Asia, not in Africa or the Americas. The knowledge was gone, erased, forgotten. And then, in 1800, Alessandro Volta announced to the world that he had discovered how to generate a continuous electric current by stacking discs of zinc and copper separated by cardboard soaked in brine. Volta believed he had invented something new. Perhaps he had. Or perhaps he had merely rediscovered something that had been known and lost, built and forgotten, 2,000 years before his birth. The original Baghdad battery is gone now. It was kept at the National Museum of Iraq in Baghdad until April 2003, when American forces invaded Iraq and toppled the government of Saddam Hussein. In the chaos that followed, the museum was looted. 15,000 artifacts disappeared in a matter of days. Cylinder seals, cuneiform tablets, jewellery, pottery, statues, and one small clay jar containing a copper cylinder and an iron rod. The Baghdad battery has never been recovered. No one knows where it is. No one knows if it still exists, if it was destroyed by the looters, if it was sold on the black market to a collector who keeps it locked in a vault somewhere, if it was simply thrown away by someone who did not understand what they had stolen. The physical evidence is gone. All that remains are the photographs, the measurements, the replicas built by modern researchers. The object itself, the actual ancient artifact, the thing that someone in Parthian Mesopotamia built with their own hands more than 2,000 years ago, has passed from the world of the known into the world of the lost, and with it, perhaps, has gone any chance of understanding what it truly was, who built it, and why. But the Baghdad Battery, unsettling as it is, fits within the boundaries of known history. The Parthians were a sophisticated civilization. They had metallurgy, chemistry, engineering. They could have discovered electrochemical principles through experimentation, through accident, through careful observation of the natural world. The battery is anomalous, but it is not impossible. The objects we must consider next are not so easily explained. South Africa, the Ottosdal region, a landscape of scrubland and mine dumps where the earth has been torn open in the pursuit of pyrophyllite, a soft talc-like mineral used in making ceramics, cosmetics, and electrical insulators. The mines here are not deep as mines go. The pyrophyllite deposits lie relatively close to the surface, in rock formations that have been dated to the Precambrian era. The Precambrian era. Let that term settle into your understanding for a moment. The Precambrian encompasses the first 4 billion years of Earth's history, from the formation of the planet to the explosion of complex life in the Cambrian period, roughly 540 million years ago. For most of the Precambrian, Earth was a world without animals, without plants, without any form of life more complex than single-celled organisms. The continents had not yet assembled into their modern configurations. The atmosphere was different. Less oxygen, more carbon dioxide and methane. The oceans were different. Everything was different. The rock from which the Klerksdorp Spheres are extracted is approximately 2.8 billion years old. 2.8 billion years. When this rock was forming, the most advanced life forms on Earth were cyanobacteria, microscopic organisms that floated in the ancient seas, slowly releasing oxygen into the atmosphere and setting the stage for all the life that would follow. Trilobites would not evolve for another 2 billion years. Dinosaurs would not appear for another 2.5 billion years. Human beings would not exist for another 2.7989 billion years. And yet, from this rock, miners have been pulling out perfectly spherical objects made of a nickel-steel alloy. The spheres range in size from about 1 to 4 inches in diameter. They are remarkably uniform in shape, not roughly spherical, not vaguely round, but geometrically precise, with deviations from perfect sphericity that are measurable only with precision instruments. Many of them have 3 parallel grooves running around their equator, spaced with what appears to be deliberate regularity. They are hard. Some of them are harder than steel, hard enough to scratch glass. They are dense. They are composed of metals, iron, nickel, and trace elements, in proportions that do not match any known natural mineral formation. Mainstream geologists have an explanation for the Klerksdorp Spheres. They are, the geologists say, concretions, natural formations created when mineral-rich water flows through porous rock, depositing layers of material around a central nucleus. Concretions are found all over the world in many different geological contexts. They can be spherical, they can be quite hard. They are a well-understood phenomenon. But the standard explanations for concretions do not account for all the properties of the Klerksdorp Spheres. They do not explain the precise grooves that encircle many of the specimens. They do not explain the metallic composition, which is unlike any concretion formed by known geological processes. They do not explain the hardness, which exceeds what would be expected from normal mineral deposition. And they do not explain what happened in the Klerksdorp Museum. In the 1980s, several of the spheres were placed on display in the Klerksdorp Museum, a small institution dedicated to the history of the region. One of the spheres was placed in a sealed glass display case, where it sat on a small pedestal, protected from touch and from the elements. Over a period of several months, museum staff noticed that the sphere was moving. Not dramatically, not rolling across the case or jumping off its pedestal, but slowly, almost imperceptibly, rotating on its own axis. The rotation was documented by multiple witnesses, including museum employees and visiting researchers. The case remained sealed. No one touched the sphere. No mechanical vibration could account for the motion. No explanation was ever offered. The sphere eventually stopped rotating, or the observations ceased, or the records were lost. The phenomenon was never scientifically investigated. It remains, like so much else about the Klerksdorp Spheres, unexplained. What are we to make of objects that appear to be manufactured, found in rock that predates the existence of manufacturing species by billions of years? What are we to make of perfect geometry in an era before geometry existed, metal alloys in an age before metallurgy, precision grooves cut by nothing that could have existed to cut them. The easy answer is that the spheres are natural, that our understanding of geological processes is incomplete, that there are mechanisms for creating hard, metallic, grooved spheres that we simply have not discovered yet. This is possible. Science often advances by explaining phenomena that once seemed inexplicable. What looks like impossibility is often just ignorance. But the easy answer carries its own weight. If we accept that our geological knowledge is incomplete enough to produce objects like the Klerksdorp Spheres through purely natural means, then what else might be hiding in the gaps of our understanding? If nature can create perfect spheres with precise grooves from nickel-steel alloys in Precambrian rock, what else can nature create that we have mistaken for impossible? And if the spheres are not natural, if they are, against all logic and all understanding, the products of some form of intelligence operating on Earth 2.8 billion years ago, then everything we think we know about the history of life, the history of intelligence, the history of our planet is wrong. Neither answer is comfortable. Neither answer lets us sleep easily. The Klerksdorp Spheres sit in their display cases and their storage drawers, waiting for someone to explain them. They have been waiting for decades. They will probably wait for decades more. And the rock from which they came continues to yield more of them, dozens and dozens of perfect spheres emerging from a world that should never have been able to produce them. This is the nature of impossible objects. They refuse to fit the narratives we have constructed about the past. They sit in museum basements and private collections, challenging us to explain them, daring us to fit them into the story we tell ourselves about human history, about natural history, about the history of the universe itself. Some of them are undoubtedly mistakes, misidentified natural formations, modern objects that became embedded in ancient rock through processes we failed to recognize, frauds perpetrated by hoaxers seeking attention or profit. The history of anomalous archaeology is littered with debunked claims and embarrassed researchers. But some of them resist debunking. Some of them present evidence that is difficult to dismiss, questions that are difficult to answer, mysteries that persist despite decades of investigation. The Antikythera Mechanism was dismissed as impossible for half a century before technology allowed us to see what was really inside it. The Baghdad battery was considered a curiosity until replicas proved that it worked. The Klerksdorp Spheres continue to emerge from rock that should not contain them, waiting for an explanation that satisfies. And in the mountains of California, in a drawer that has not been opened in decades, sits an object that makes all of these look almost ordinary by comparison. The Coso Mountains rise from the Mojave Desert, in a series of barren ridges and volcanic formations, their slopes littered with the geological detritus of millions of years. This is a landscape of extremes, blisteringly hot in summer, freezing in winter, perpetually dry, perpetually wind-scoured. Few people live here, fewer visit, the land belongs to the rocks and the things buried within them. On February 13th, 1961, 3 men drove into these mountains looking for geodes. Their names were Wallace Lane, Virginia Maxey, and Mike Mikesell, amateur prospectors who supplemented their incomes by collecting and selling the round, crystallined rocks that the Coso Range occasionally yielded. Geodes form when gas bubbles in volcanic rock create hollow cavities that slowly fill with mineral crystals over millions of years. Cut one open, and you might find a glittering interior of amethyst or quartz, a miniature cathedral of crystal spires that can fetch good money from collectors and tourists. The 3 prospectors spent the day gathering promising nodules, fist-sized lumps of hardite, a type of calcium-rich rock that often surrounds geodes in this region. They loaded their finds into their vehicle and drove back to Olancha, California, where Mikesell ran a small rock shop. The following day, February 14th, he began the tedious work of cutting open their haul, hoping to find specimens worth selling. Most of the nodules contained exactly what he expected. Crystal formations of varying quality, some commercially viable, most not. But when his diamond-edged saw blade bit into one particular specimen, something unexpected happened. The blade, a tool designed to cut through stone, began to struggle. The rock was harder than it should have been. Much harder. When Mikesell finally worked through the outer layer, the blade hit something that nearly ruined it entirely. Inside the rock, surrounded by what appeared to be standard geological material, was an object that had no business being there. The prospectors stared at what the saw had revealed. Embedded in the centre of the nodule, perfectly encased in solid stone, was a manufactured cylinder. It was about the size of a human finger, roughly 3/4 of an inch in diameter and approximately an inch and a half long. A hexagonal sleeve of what appeared to be heavily corroded copper or bronze surrounded it. Inside the hexagonal sleeve was a ceramic cylinder, and inside the ceramic cylinder was a metal core, its surface showing signs of corrosion but its shape unmistakably regular, unmistakably machined. At first, the prospectors assumed they had found some kind of natural formation that merely resembled a manufactured object. This happens frequently in geology. Concretions and mineral deposits can create shapes that look man-made but are entirely natural. But as they examined the object more closely, that explanation became increasingly difficult to sustain. The ceramic material surrounding the metal core was uniform in thickness and composition. The hexagonal sleeve was precisely hexagonal. Not approximately, not vaguely, but geometrically perfect. The metal core showed evidence of machining marks, and at one end of the cylinder, barely visible through the corrosion and the surrounding rock, was something that made all three prospectors fall silent. It was a spring, or a washer, or some kind of threaded component. Whatever it was clearly mechanical, it was clearly manufactured, and it was clearly impossible. The rock surrounding the object was not loose sediment that might have formed around a modern artifact dropped into a crack or cavity. It was solid hard ice, showing no fissures, no recent intrusion, no evidence that anything had penetrated its surface in geological ages. The mineral inclusions embedded in the stone showed the characteristic patterns of slow formation over vast stretches of time. Whatever this object was, it had been there for a very, very long time. How long? That was the question that would consume the prospectors and eventually a small community of researchers who became fascinated by what came to be known as the Kozo artifact. Virginia Maxey, who had some connections in the local geological community, arranged for the object to be examined by a geologist named Ron Calais. Calais studied the outer shell of the nodule and made an estimate that would transform the artifact from a curiosity into an impossibility. Based on the mineral composition and the fossil shells embedded in the outer layer of the rock, he assessed the formation to be approximately 500,000 years old, 500,000 years. An object that looked like a piece of early 20th century industrial equipment, sealed inside rock that formed when Homo erectus was still the dominant human species, when modern humans did not yet exist, when the wheel had not been invented, when fire was humanity's most advanced technology. The prospectors knew they had something extraordinary. They also knew that the scientific establishment would dismiss their find unless they could document it thoroughly. They arranged for the artifact to be X-rayed, and the resulting images only deepened the mystery. The X-rays revealed internal structure that was strikingly regular. The metal core was perfectly cylindrical, with no variation in diameter along its length. The ceramic sleeve surrounding it was uniform in thickness, and at the upper end of the assembly, clearly visible in the radiographic images, was a small component that looked for all the world like a compressed spring or a threaded connector, the kind of precision-machined part that would not be mass-produced until the Industrial Revolution. A professional photographer named Paul Willis was brought in to document the artifact. His photographs, taken in the weeks following the discovery, remain the primary visual record of the object. They show a corroded but recognizable cylindrical assembly, its geometry too regular to be natural, its components too complex to be accidental. Word of the discovery spread through the small community of anomalous archaeology enthusiasts who existed on the fringes of mainstream science. Researchers came to examine the artifact. Theories proliferated. Some suggested it was evidence of a lost human civilization that predated recorded history. Others proposed that it might be extraterrestrial in origin, a piece of debris from some ancient visitor that had become embedded in terrestrial rock. A few suggested time travel, arguing that a modern object had somehow been transported into the distant past. The scientific mainstream, predictably, dismissed all of these theories. Geologists pointed out that Calais' age estimate was based on a superficial examination of the outer shell, not rigorous radiometric dating. They argued that the geode might not be a geode at all, but rather a concretion, a mass of mineral material that can form relatively quickly around a foreign object under certain conditions. If a modern artifact had fallen into a crack in older rock and become embedded in mineral-rich groundwater, a concretion could theoretically form around it in decades rather than millennia. This explanation would mean that the Koso artifact was nothing more than a piece of early 20th century technology, perhaps a spark plug from a Model T Ford or a mining vehicle, that had become naturally cemented into rock within living memory. The outer shell was old, the object inside was not. But the skeptical explanation had problems of its own. The prospectors and subsequent examiners insisted that the rock showed no fissures, no evidence of recent formation, no indication that anything had penetrated its surface. The mineral composition of the encasing material was consistent with ancient formation processes, not rapid concretion. And the object itself, while resembling a spark plug in its general configuration, did not match any known spark plug design from any era. Researchers compared the artifact to vintage spark plugs from the 1920s and earlier. The dimensions were similar but not identical. The internal structure differed in subtle but important ways. If this was a modern artifact that had become encased in rock, it was not a standard industrial component. It was something unusual, something that did not match any known production model. For several years after its discovery, the Koso artifact remained accessible to researchers who sought to examine it. The prospectors displayed it at their rock shop. They allowed X-rays and photographs. They participated in interviews and investigations. The artifact became a minor celebrity in the world of anomalous archaeology, featured in books and articles about unexplained objects. And then, sometime in the late 1960s, it vanished. The circumstances of its disappearance are murky. Wallace Lane reportedly kept possession of the artifact after the initial wave of interest subsided. Over time, his cooperation with researchers diminished. He stopped responding to inquiries. He stopped allowing access to the object. And eventually, no one knew where the artifact was or what had happened to it. Lane died in 2014. By that time, the Koso artifact had been missing from public view for nearly half a century. No one knows what he did with it. No one knows whether it still exists. The only documentation of its existence is the original X-rays, the photographs taken by Paul Willis, and the testimonies of those who examined it in the months following its discovery. A single object that might have been evidence of impossible antiquity, or might have been a misidentified modern artifact, lost before it could ever be subjected to rigorous scientific analysis. We will likely never know the truth. The Koso artifact has joined the long list of anomalous objects that tantalize with their implications and frustrate with their inaccessibility. But the questions it raised have not disappeared. If the skeptics are right, then we have learned something important about the formation of concretions and the dangers of misidentifying geological processes. If the believers are right, if the object really was sealed in rock 500,000 years ago, then we have lost one of the most important artifacts in human history, lost it to carelessness or deliberate concealment, lost it in such a way that we can never recover it. And either way, we are left with the same unsettling truth that runs through all of these objects. We do not know what we have lost. We do not know what might be sitting in basements and attics and museum drawers, waiting for someone to recognize their significance. We do not know what has already been thrown away, destroyed, buried again, forgotten. The past is not a neatly organized archive. The past is a storm that has been raging for billions of years, and most of what it once contained has been scattered beyond all recovery. In the summer of 1936, while the world's attention was focused on the gathering clouds of war in Europe and the economic devastation of the Great Depression in America, a couple went hiking in the hill country of central Texas. Their names were Max and Emma Hahn, and they had no particular destination in mind. Just a pleasant afternoon walk through the scrubland and limestone formations near the small town of London, about 80 miles northwest of Austin. The terrain around London is typical of the Texas hill country, rolling hills covered with cedar and oak, underlain by thick beds of limestone and dolomite laid down during the Cretaceous period, when much of Texas was covered by a shallow tropical sea. The rocks here are old. Some formations date back more than 100 million years, to an era when dinosaurs roamed the land that would become Texas, and marine reptiles swam in the waters above what are now farms and cattle ranches. As the Hahns walked along a small creek bed, Emma noticed something unusual. A piece of wood was protruding from a chunk of rock lying in the stream bed, not near the rock or beside the rock, but emerging from the rock itself, a wooden handle, weathered but unmistakable, sticking out of solid stone. The Hahns picked up the rock and carried it home. It was heavy. The stone portion weighed several pounds, but the wooden handle provided a convenient grip. They showed it to friends and neighbours. Everyone agreed it was peculiar, but no one knew quite what to make of it. The rock went into storage, and life continued. Nearly a decade later, in 1946 or 1947, the Khan's son George decided to satisfy his curiosity about what was attached to that wooden handle. He took a hammer and chisel to the rock and carefully broke away enough stone to reveal what was inside. It was a hammerhead, a standard-looking iron hammerhead attached to the wooden handle completely encased in solid limestone. The hammer appeared to be a mining or prospecting tool, the kind of implement that might have been used by anyone working in the Texas hills during the 19th century. At first glance, there was nothing unusual about it except for the peculiar fact of its encasement. Limestone can form around objects relatively quickly under the right conditions, and a hammer lost by a miner in the 1800s might theoretically become embedded in mineral deposits over the course of a century or so. But as more people examined the hammer, inconsistencies began to emerge. The iron of the hammerhead was unusual. When it was eventually analysed, the metal was found to be approximately 96.6% pure iron, with small amounts of chlorine and sulphur, but virtually no carbon. This composition is extraordinarily difficult to achieve. Modern iron and steel production almost always introduces carbon into the metal. It is what makes steel stronger than pure iron. An iron tool with this level of purity would require either exceptionally primitive smelting techniques that predate the introduction of carbon hardening processes, or extraordinarily advanced refining techniques that remove carbon after smelting. A 19th century mining hammer should fall somewhere in between. Iron with a significant carbon content, the standard composition of industrial era tools. The wooden handle presented its own mysteries. At one end, the end that had been deepest inside the rock, the wood had begun to transform. It was no longer entirely wood. The cellular structure remained visible, but the material had become partially mineralized, turning from organic wood toward inorganic coal. This process, known as coalification, typically requires millions of years. A piece of wood that had been buried for only a century or two should show no coalification whatsoever. The fact that the handle had begun to petrify suggested it had been in its environment for far longer than any 19th century origin would allow. And then there was the rock itself. The limestone encasing the hammer was not loose sediment or recent concretion. It was solid stone, continuous with the geological formations of the surrounding region. Some researchers who examined the rock claimed that it matched the Cretaceous-era limestone prevalent in the London area, formations that were laid down more than 100 million years ago. If the rock was truly Cretaceous limestone, then the hammer had been embedded in it for at least 100 million years. This would place its creation in an era when Texas was underwater, when the dominant land animals were dinosaurs, when mammals were small and primitive, when human beings would not exist for another 95 million years or more. The implications were, quite simply, impossible. For decades, the hammer remained in private hands, passed down through the Hahn family and occasionally examined by curious researchers. In 1983, it was acquired by Carl Bohr, a creationist who founded the Creation Evidence Museum in Glen Rose, Texas, a small institution dedicated to presenting evidence that the Earth is much younger than mainstream science claims, and that humans and dinosaurs coexisted. Bohr saw the hammer as proof of his worldview. If human artifacts could be found in rock supposedly millions of years old, then either the rock was much younger than geologists claimed, or the conventional timeline of human history was wrong. Either way, the hammer supported his belief that mainstream science had fundamentally misunderstood the past. The hammer became one of the museum's signature exhibits. It was displayed prominently, presented to visitors as evidence that challenged evolutionary timelines. It appeared in creationist literature and websites, cited as proof that the geological column was unreliable, and that human civilization was far older, or the Earth far younger, than scientists acknowledged. Mainstream scientists, unsurprisingly, rejected this interpretation. Geologists who examined photographs of the artifact argued that the encasing rock was not Cretaceous limestone, but rather a much more recent concretion. Dissolved calcium carbide in groundwater can precipitate around objects relatively quickly, creating a limestone-like encasement in decades or centuries rather than millions of years. A hammer lost by a 19th century miner, buried in calcium-rich soil, exposed to mineral-laden groundwater, could theoretically become encased in hard rock within a human lifetime. This explanation accounts for the hammer's encasement without requiring impossible antiquity. But it does not fully account for the unusual composition of the iron, or the partial coalification of the handle, or the absence of any obvious concretion boundary between the encasing rock and the surrounding geological formations. And here we encounter a problem that has plagued the study of the London hammer from the beginning. The object has never been subjected to independent, rigorous scientific analysis. It has remained in the possession of the Creation Evidence Museum since 1983. The museum has allowed some examination by outside researchers, but it has never permitted the kind of comprehensive study, involving radiometric dating of the rock, metallurgical analysis of the iron, chemical analysis of the partially fossilized wood, that would be necessary to definitively determine the hammer's age and origin. The museum's critics argue that this reluctance is telling. If the hammer truly supported young Earth creationism, they say, the museum would have every incentive to allow exhaustive testing that would prove its claims. The fact that they have not done so suggests that they fear what such testing might reveal. The museum's defenders counter that they have no obligation to submit their artifacts to institutions that are ideologically committed to dismissing any evidence that challenges mainstream timelines. They argue that mainstream scientists have already made up their minds about the hammer and would find ways to explain away any anomalous results. And so the hammer sits in its display case in Glen Rose, Texas, examined by thousands of visitors every year, subjected to endless speculation but never to the comprehensive analysis that might settle the questions it raises. Like the Koso artifact, like the Baghdad battery, like the Klerksdorp Spheres, it exists in a state of permanent ambiguity, too strange to ignore, too poorly documented to accept, too politically charged to examine objectively. What would it mean if the hammer were genuine? If it really was an iron tool forged by human hands, embedded in rock that formed 100 million years ago, it would mean that everything we think we know about the history of our species is wrong. It would mean that human beings, or something very like them, existed on Earth alongside the dinosaurs. It would mean that our entire understanding of evolution, of geological time, of the development of technology, is built on false foundations. But it might also mean something else. It might mean that the universe is stranger than we imagine, that time does not flow in the simple linear fashion we assume, that objects can move backward through the ages in ways we cannot explain. It might mean that what we call impossible is merely unexplained, that the boundaries we have drawn around reality are lines in sand waiting for the tide to wash them away. Or the hammer might be exactly what the skeptics claim, a 19th century tool that became encased in relatively recent concretion, its unusual iron composition the result of an unusual but not impossible smelting process, its partially fossilized handle the result of accelerated mineralization in an unusually mineral-rich environment. A mundane object, misinterpreted by people who wanted it to be something more. We do not know. We may never know. The hammer keeps its secrets, as so many of these objects do. What these artifacts share, the Antikythera Mechanism, the Baghdad battery, the Klerksdorp Spheres, the Koso artifact, the London hammer, is not a common origin or a common explanation. They may have nothing to do with each other. They may all be examples of misidentification, wishful thinking, fraud, or the simple human tendency to see patterns and purposes where none exist. But they also share something else. They are all objects that, if genuine, would force us to radically revise our understanding of the past. They are all challenges to the comfortable narratives we have constructed about human history, technological development, and the nature of intelligence itself. The Antikythera Mechanism tells us that the ancient Greeks were capable of building computers 2,000 years before the Industrial Revolution. The Baghdad battery tells us that Mesopotamian civilizations understood electricity 2,000 years before Volta. The Klerksdorp Spheres suggest that something was creating precise metallic objects on Earth billions of years before life as we know it evolved. The Koso artifact and the London hammer hint that technological artifacts might exist in geological contexts that predate humanity entirely. Each of these objects, taken individually, might be explained away. Natural concretions, misidentified formations, recent artifacts embedded in ancient rock through processes we failed to recognize, hoaxes perpetrated by attention seekers or ideologues. The history of anomalous archaeology is full of such explanations, and many of them have proven correct. But taken together, these objects form a pattern that is harder to dismiss. They suggest that our knowledge of the past is far more incomplete than we like to admit. They suggest that advanced technologies may have existed, flourished, and vanished without leaving any trace in the historical record. They suggest that the story we tell ourselves about human progress, a steady climb from primitive ignorance to modern sophistication, may be a fairy tale, a comforting fiction that obscures a far more complex and disturbing reality. What if technological civilizations have risen and fallen multiple times throughout Earth's history? What if the peaks of achievement were followed by catastrophic collapses that erased almost all evidence of what had been accomplished? What if the Renaissance, the Industrial Revolution, the Information Age are not unprecedented leaps forward, but rather recapitulations of achievements that were made and lost countless times before? These are not comfortable questions. They challenge the foundations of modern science, modern history, modern archaeology. They suggest that the experts who have spent their careers constructing our understanding of the past may have built their edifice on sand. But they are questions that the evidence demands we ask, because the objects are real. The Antikythera Mechanism is real. You can see it in the National Archaeological Museum in Athens, its gears corroded but still visible, its sophistication still impossible to fully explain. The Baghdad battery is real, or was, before it disappeared into the chaos of war. The Klerksdorp Spheres are real, still being pulled from mines in South Africa, still waiting for an explanation. The London hammer is real, still sitting in its display case in Texas, still daring someone to prove what it is or what it is not. The Koso artifact was real. The photographs and X-rays remain. The testimonies of those who examined it remain. Somewhere, in a drawer or a safe or a landfill, the object itself may still exist, waiting to be rediscovered, waiting to have its secrets finally unlocked. Or it may be gone forever, destroyed or discarded, another piece of the puzzle that we will never recover. This is perhaps the most unsettling aspect of all. We cannot know what we have lost. For every anomalous object that has been found and documented and preserved, how many have been thrown away as curiosities? How many have been destroyed by researchers who could not believe what they were seeing? How many lie buried in museum basements, mislabeled and forgotten, waiting for someone to recognize their significance? The past is not a book that we can read from beginning to end. The past is a palimpsest, a manuscript that has been written and erased and written over countless times, each new layer obscuring what came before. We read the topmost layer and imagine we understand the whole document, but beneath our feet lie depths we cannot see, containing secrets we cannot imagine, and in those depths something waits. Consider for a moment the mathematics of preservation. Consider what it actually takes for an object to survive across millennia, across geological ages, across the vast and indifferent grinding of time. Metal rusts, wood rots, stone erodes. Even the most durable materials we know, ceramics, glass, certain alloys, degrade and crumble when exposed to the relentless assault of water, temperature fluctuation, microbial action, tectonic pressure. The oldest human artifacts we possess are typically made of stone, and even those survive only because stone happens to be relatively resistant to the forces that destroy everything else. But what of materials that are not stone? What of textiles, papers, electronic components, polymers, biological specimens? The half-life of preservation for such materials is measured in decades, not millennia. A civilization that relied primarily on organic materials, as many advanced civilizations might, for reasons of sustainability or technological sophistication, would leave almost no trace after a few thousand years. After a few million years, it would be as if they had never existed at all. Now extend this calculation backward through deep time. The Earth is 4.5 billion years old. Complex multicellular life has existed for roughly 600 million years. Anatomically, modern humans have existed for perhaps 300,000 years. Our recorded history spans only about 5,000 years. Industrial civilization is barely 250 years old. Digital civilization is less than 50 years old. If you compressed the entire history of Earth into a single 24-hour day, all of recorded human history would occupy less than a second. The entire span of technological civilization, everything from the first smelted bronze to the smartphone in your pocket, would be a fraction of a blink. In that fraction of a blink, we have already transformed the planet. We have left our mark on every continent, in every ocean, in the very atmosphere itself. But how long would that mark last if we vanished tomorrow? How long before the bridges rusted and fell, the highways cracked and crumbled, the skyscrapers collapsed into rubble and were slowly consumed by vegetation? How long before the plastic degraded and the metals oxidized and the concrete dissolved back into the limestone from which it came? The answer, according to every geological and archaeological estimate, is distressingly brief. Within a few hundred years, almost all visible evidence of our civilization would be gone. Within a few thousand years, the Earth would look as if we had never been here. Within a few million years, even the most durable traces, the deep mines, the depleted uranium, the altered isotope ratios in certain rock strata, would be difficult to detect without knowing exactly what to look for. Within a few 100 million years, even those traces would be erased, subducted into the Earth's mantle by plate tectonics or buried beneath miles of sediment. This is the Silurian hypothesis, named not for a real geological period but for a fictional alien race in a British science fiction television programme. The hypothesis asks a simple question. If an industrial civilization had existed on Earth hundreds of millions of years ago, would we be able to detect it today? And the answer, according to the scientists who have seriously studied the question, is probably not. We would have to look for extremely subtle signatures, anomalous spikes in certain chemical elements, unusual patterns in the geological record, perhaps the occasional object that somehow survived against all odds, encased in rock or preserved in amber or lost in the depths of the sea. Objects perhaps like the ones we have been examining. This is where the story becomes truly vertiginous, because we have been asking the wrong question all along. We have been asking, how could the ancient Greeks have built a computer? How could the Mesopotamians have discovered electricity? How could a spark plug end up in 500,000-year-old rock? But the more fundamental question is, why do we assume that our civilization is the first? Why do we assume that the technological trajectory we have followed, from fire to agriculture to industry to computing, has never been followed before? Why do we assume that in the 4.5 billion years of Earth's existence, in the 600 million years since complex life appeared, in the countless opportunities for intelligence to evolve and flourish and build, we are the only ones who ever did? The answer, of course, is that we assume this because the evidence tells us so. The geological record, as we read it, shows no trace of prior industrial civilizations. The fossil record shows no tool-using species before the hominids. The archaeological record shows no sophisticated technology before the Bronze Age. But this is circular reasoning. We have defined evidence in such a way that only certain types of traces count, and then we have concluded that because we find no traces of the type we are looking for, no prior civilizations existed. We have looked for our own reflection in the mirror of the past and, finding only our own face staring back, concluded that no other face was ever there. But the anomalous objects suggest otherwise. They suggest that our mirror may be cracked. They suggest that faces may appear in the glass that we did not expect to see. Faces that look nothing like our own. Faces that should not be there. Faces that we cannot explain. And so we must consider the possibilities. We must consider them carefully, rationally, without the comfort of easy answers or the refuge of premature certainty. We must consider what it would mean if any of these objects were genuine, if any of them actually represented technology from a time before technology was supposed to exist. The first possibility is the most conservative, that all of these objects are exactly what the skeptics say they are. The Antikythera Mechanism, while remarkable, was simply the product of a more advanced Greek scientific tradition than we previously knew existed, a tradition that flourished briefly and then was lost when the Romans conquered the Greek world, not because of some mysterious catastrophe, but simply because the Romans were more interested in engineering than in astronomy, more focused on roads and aqueducts than on mechanical calendars. The Baghdad battery was not a battery at all, just a storage vessel whose resemblance to an electrochemical cell is coincidental, and the fact that it produces electricity when filled with acid is merely an accident of its construction, never intended by its makers. The Klerksdorp Spheres are natural concretions, unusual but not impossible, formed by mineral processes that we do not yet fully understand. The Koso artifact was a modern spark plug embedded in relatively recent rock through a process of rapid mineral accretion, misidentified by prospectors who lacked the expertise to recognize what they were looking at. The London hammer was a 19th century mining tool dropped into a crevice and encased in limestone through ordinary geological processes. its unusual metallurgy explained by some quirk of its original manufacture. This is the safe interpretation. This is the interpretation that requires no revision of our understanding of history, no overturning of established scientific consensus. And for many people, it will be the satisfying interpretation, the one that allows them to sleep soundly at night, confident that the world is as they have always believed it to be. But notice what this interpretation requires. It requires us to believe that the most sophisticated mechanical computer of the ancient world was built by a civilization that left no other evidence of such mechanical sophistication. It requires us to believe that the Parthians accidentally created a working battery without ever discovering what it could do. It requires us to believe that natural mineral processes can create objects that appear precisely manufactured, objects with perfect symmetry, parallel grooves, unusual metallic compositions, through pure chance. It requires us to believe that modern industrial artifacts can become embedded in stone so seamlessly that trained geologists cannot distinguish the encasement from genuine ancient rock. It requires us to believe, in short, that the universe is full of astonishing coincidences that just happen to mimic the appearance of lost technologies. Perhaps the universe is indeed full of such coincidences, but the pattern of the evidence gives us pause, because each of these objects individually might be explained as a coincidence. But when we find multiple objects from different times and places, all pointing toward the same conclusion, that advanced technologies may have existed in the distant past, the probability of coincidence begins to shrink. At some point we must ask ourselves, how many coincidences can we accept before coincidence itself becomes the less plausible explanation? The second possibility is more unsettling, that some of these objects are genuine, but they represent isolated achievements rather than evidence of lost civilizations. On this view, the Antikythera Mechanism was the work of a single brilliant inventor, a Heron of Alexandria perhaps, or an unknown genius whose name history has forgotten, who managed to create something far beyond the capabilities of his culture, a one-off masterpiece that was never replicated because no one else understood how it worked. The Baghdad battery might represent a similar isolated discovery, a fortunate accident of experimentation that produced an electrochemical effect without leading to any broader understanding of electricity. Even the more extreme objects, the Klerksdorp Spheres, the Koso artifact, the London hammer, might be explained as the products of isolated events, anomalies that do not fit any pattern because there is no pattern to fit. This interpretation preserves the basic outline of human history, while acknowledging that individual achievements may occasionally far exceed the general level of their time. It allows for the possibility that genius can appear anywhere at any moment and create things that seem impossible in retrospect. It suggests that the past may contain more surprises than we have imagined, but not that our fundamental understanding of the past is wrong. But this interpretation has its own problems, because the Antikythera Mechanism was not found alone. It was found on a ship, along with other cargo, suggesting that it was a trade good, a product being transported from one place to another. This implies that there was a market for such devices, a demand that the mechanism was meant to fulfill, and a market implies multiple customers, multiple producers, an entire industry of mechanical computing that we have somehow lost all other evidence of. The same logic applies to the Baghdad battery. If multiple similar jars have been found across Mesopotamia, then we are not looking at a single isolated experiment, but at a technology that was widespread enough to leave multiple examples in the archaeological record. These were not accidents. These were products of knowledge, systematic, transmissible knowledge that must have existed in the minds of multiple people, in the workshops of multiple craftsmen, in the economies of multiple cities. And yet that knowledge vanished. It disappeared so completely that when we rediscovered electricity in the 18th century, when we reinvented mechanical computation in the 17th century, we had no idea that anyone had been there before us. We thought we were pioneers. We thought we were seeing these territories for the first time. We had no memory, no tradition, no legend that suggested otherwise. This brings us to the third possibility, the most disturbing of all, that these objects are fragments of lost civilizations, civilizations that achieved technological sophistication comparable to or exceeding our own, and then collapsed so completely that almost all evidence of their existence was erased. Civilizations that may have risen and fallen multiple times throughout Earth's long history, each cycle separated by gaps so vast that no memory could bridge them, no artifact could survive intact, no record could endure. This possibility sounds like science fiction. It sounds like the fever dream of conspiracy theorists, the fantasy of those who cannot accept that our civilization is unique. But consider what it would actually require. It would require that intelligence has evolved on Earth more than once. This is not as implausible as it sounds. Intelligence has evolved independently in multiple lineages, in cephalopods, in corvids, in primates, in cetaceans. The brain structures are different, the evolutionary pathways are different, but the outcome is similar. Creatures that can solve problems, use tools, communicate complex information, learn from experience. If intelligence can evolve independently multiple times within a single geological epoch, why not across the vast spans of deep time? The dinosaurs dominated the Earth for 165 million years, far longer than mammals have been dominant. In that time, some lineages became surprisingly sophisticated. The troodontids, for example, were small bipedal predators with unusually large brains, forward-facing eyes, and grasping hands. They were becoming more intelligent over time. If the asteroid had not struck, if the dinosaurs had been given another 10 million years, another 100 million years, what might have emerged? And the dinosaurs themselves were preceded by other lineages, other experiments in life, other opportunities for intelligence to evolve. It would require that such civilizations left almost no trace. This is where the Silurian hypothesis becomes relevant. As we have seen, the geological processes that shape the Earth are remarkably effective at erasing evidence. Over millions of years, mountains are worn down to plains, continents drift and collide, the very rocks are recycled through the mantle and re-emerged as new formations. Any civilization that existed more than a few 100 million years ago would have left its artifacts in rock that has since been transformed, subducted, melted, and reformed countless times. Only the most fortunate accidents of preservation could allow anything to survive. An artifact encased in an unusually stable rock formation, protected from heat and pressure, isolated from chemical processes, waiting for the improbable moment when human eyes would find it. It would require that the survivors of such collapses failed to pass on their knowledge. But this too is not implausible. Consider how much of our own civilization depends on infrastructure, on institutions, on the accumulated knowledge stored in libraries and databases and the minds of specialists. If our civilization collapsed tomorrow, if a pandemic killed 90% of the population, if a nuclear war destroyed the major cities, if a climate catastrophe made most of the planet uninhabitable, how much of our knowledge would survive? The survivors would know that their ancestors had built great things. They would tell stories about flying machines and talking boxes and lights that turned on at the touch of a switch. But could they rebuild those machines? Could they explain the principles behind them? Could they transmit the precise technical knowledge required to recreate them? Or would that knowledge die with the specialists who possessed it, leaving only myths and legends, fading memories of a golden age that the descendants could not even fully imagine, let alone replicate? We have evidence that this has happened on smaller scales within recorded history. The Romans knew how to make concrete that hardened underwater, that was stronger and more durable than anything we could produce until the 20th century. The recipe was lost for over 1,000 years. The Stradivari knew how to make violins that produced a tone that modern craftsmen, despite centuries of effort and all the advantages of modern science, have never been able to replicate. The secret died with the family. The Maya had astronomical calculations accurate to within minutes over thousands of years. The Spanish burned their books. The Greeks had steam engines, mechanical theatres, automatic doors. The knowledge was not destroyed by any single catastrophe. It simply faded away as the civilization that created it declined, as the institutions that preserved it crumbled, as the people who understood it grew old and died without successors. Now multiply this by tens of millions of years. Multiply it by the yawning gulf between the Cretaceous period and the present day. Multiply it by extinction events that wiped out not just individuals or cities or civilizations, but entire lineages, entire ecosystems, entire worlds of life. In such a context, the loss of all memory, all tradition, all evidence becomes not just plausible but inevitable. The only surprise would be if anything survived at all, and yet, perhaps, something did. This is the final turn of the spiral, the point at which speculation passes beyond what can be tested or verified and enters the realm of pure wonder. Because if we take seriously the possibility that technological civilizations have risen and fallen multiple times throughout Earth's history, then we must also take seriously the possibility that some trace of their existence might still be found. Not much, not a library, not a city, not even a readable text, but fragments, anomalies, objects that should not exist, that do not fit, that point toward mysteries we cannot solve with the tools we currently possess. The Antikythera Mechanism, the Baghdad Battery, the Klerksdorp Spheres, the Koso artifact, the London Hammer. We do not know what these objects are. We may never know. The evidence is fragmentary, the analysis incomplete, the provenance often suspect. Any or all of them might turn out to have perfectly mundane explanations that we simply have not yet discovered. The history of anomalous archaeology is full of objects that seemed inexplicable, until someone finally explained them. Mysteries that remained mysteries only as long as no one looked closely enough. But the history of science is also full of discoveries that were dismissed as impossible until they were proven true. Continental drift was dismissed as fantasy until the mechanism of plate tectonics was understood. Ball lightning was considered a folk legend until it was finally captured on video. The giant squid was a myth until one was caught. The coelacanth was extinct for 65 million years, until one was pulled from the waters off South Africa. The past has a way of keeping its secrets, and the ocean of time is deeper than we can fathom. In the National Archaeological Museum in Athens, behind protective glass, the Antikythera Mechanism waits. Its gears have not turned in 2,000 years. Its bronze has corroded to the colour of sea foam. But the mathematical relationships encoded in its structure remain intact. The ratios of the gears, the cycles of the celestial bodies, the astonishing precision that has made it an object of wonder to everyone who has studied it. Somewhere in its ruined complexity lies the answer to a question we have not yet learned how to ask. Somewhere in its silence is a voice from the ancient world, trying to tell us something about what once was and what was lost. In the museums and laboratories and private collections of the world, other objects wait as well. Some have been studied extensively. Others have been ignored or forgotten. Still others have been lost, stolen, destroyed, misplaced, abandoned to the entropy that claims all things eventually. Each loss is a closing of a door, an answer that we will never receive, a piece of the puzzle that has slipped through our fingers into the darkness of the unknown. And beyond the objects we have found lie the objects we have not found, the countless artifacts that must have existed and must have been destroyed, the technologies that flourished and faded, the civilizations that rose and fell without leaving any witness to their existence. Every ploughed field, every construction site, every mine and quarry and excavation is a lottery ticket, a chance to pull something from the depths that will change everything we think we know. Most tickets are blank. Most discoveries are ordinary, but every once in a while someone splits open a rock and finds something impossible inside. What happens next is up to us. We can dismiss the impossible thing, explain it away, file it under curious but unimportant, and move on with our comfortable certainties intact. Or we can pause, we can look, we can ask the questions that the evidence demands, even if the answers threaten to overturn everything we thought we understood. The past is not a closed book. The past is a palimpsest, a document written and erased and written over countless times. We read the topmost layer and imagine we understand the whole, but beneath our feet lie depths we have never seen, containing secrets we cannot imagine. The objects we have examined are not answers, they are invitations. They invite us to look deeper, to question more thoroughly, to hold our certainties more lightly. They invite us to remember that the universe is older and stranger, and more full of wonders than any single generation can comprehend. 2,000 years ago, on a ship crossing the Mediterranean, someone carried a device that could predict the heavens. That person knew how the device worked, knew who had made it, knew what tradition of knowledge it represented. That person is gone now. The ship is wreckage at the bottom of the sea. The knowledge that created the mechanism has been erased from human memory. We hold the object in our hands and we cannot read it. We cannot fully understand it. We can only marvel at what it implies about what once was and what we have forgotten. What else have we forgotten? What else lies buried in the sediment of ages waiting for the day when someone will dig it up and recognize it for what it is? What civilizations rose and fell before the first humans walked the earth? What technologies flourished in ages so remote that even the rocks have forgotten them? What songs were sung? What stories told? What dreams dreamed by beings we will never know existed? We cannot answer these questions. Perhaps we will never answer them. But we can hold them in our minds. We can let them humble us, remind us of our smallness, of the brevity of our time on this ancient earth. We can look at the stars that the makers of the Antikythera Mechanism tracked across the sky and know that those same stars shone down on worlds and ages we cannot imagine. We can touch the objects that remain and feel, through them, the presence of minds that once existed and wondered and built and were forgotten. The past is not dead. The past is not even past. It lives on in the objects that survive it, in the questions those objects raise, in the wonder they inspire in anyone who looks at them with open eyes. And somewhere, in the darkness of deep time, it waits for us to remember.